Back in October, I became a bit obsessed with ferrofluid, and I really wanted to try making it myself. So I looked online and I found a bunch of different procedures, and it seemed to be quite straightforward. However, when I tried them, none of them seemed to work. When a ferrofluid goes near a magnet, or just a magnetic field in general, it should easily form these weird looking spikes, and it should also still look like a fluid. What I made, though, either just didn't do much of anything, or it partially solidified and formed these semi-solid spikes. I actually thought that this was still kind of cool, but it was far from being a proper ferrofluid. Not being able to make it, and the fact that there was no decent recipe for it anywhere, honestly really frustrated me. So, I kind of went into full tryhard mode, and I started reading every piece of relevant information that I could find. Then, I just started trying different things, and about a month later, I was eventually successful. I was actually able to make some really nice ferrofluid, and it spiked even better than the commercial stuff. For my last video, I had to buy the ferrofluid to get this shot, but this time, this is the stuff that I made. With a side-by-side comparison, you can see that the spikes in mine are actually sharper and bigger. When it comes to making ferrofluid, the general idea is quite simple. It's basically just a stable suspension of a magnetic iron compound in a solvent. In practice, though, it's a bit harder, and it's not as simple as just mixing these two things together. The magnetic iron compound, which is usually magnetite, has to first be specially prepared as nanoparticles and then chemically coated with something to make them stable. So the question now is, how did I do it? And well, that's kind of the point of this video. I'm going to be showing you guys exactly what I did, and the first step was to make the magnetite. To do this, I needed a source of iron 3+ and iron 2+ ions. In my last video, I used ferric chloride that I made for the iron 3+ and ferrous sulfate that I bought for the iron 2+. However, this really wasn't the best way to do it. Preparing both of them myself requires a lot of time and effort, and neither of them end up being super pure. I found that it was way easier and cheaper to just use circuit board etchant. This stuff is really easy to get, and I picked up 4 liters of it from a local store for only about $50. It's about 40% ferric chloride, aka iron 3 chloride, and I used it directly as my iron 3+ source. To get the iron 2+, though, I had to make it myself from the 3+ etchant, but it was quite easy. All I had to do was reduce these 3+ ions to 2+ ions using steel wool. So into a beaker, I poured in some of the ferric chloride, and I also dumped in some steel wool. It started reacting almost immediately, and the iron 3 was being reduced to iron 2. In doing so, 2 iron 3 ions were turning into 3 iron 2 ions, which meant that the concentration was increasing. A lot of procedures that I saw online, though, didn't take this at all into account, and they assumed that the concentration was staying the same. However, in the end, I was going to have 1.5 times more iron 2 ions than the iron 3 that I started with, and this was very important to be aware of. This is because later on, when I make the magnetite, I'm going to have to mix the iron 2 solution that I made with more iron 3, and the ratio between the two is very important. Messing this up, especially by a huge factor like 1.5, would definitely lead to poor quality magnetite and ruin the whole preparation. This process was exothermic, meaning it released heat, and because of this, the solution slowly heated up. This extra heat was actually a good thing though, because it caused the reaction to go a lot faster. Over the course of just several minutes, the dark red-orange color from the iron 3 slowly disappeared and it started turning green from all the iron 2. The basic idea here was to keep adding the wool until it pretty much stopped reacting, and then to just let it sit there for a bit. I came back about 10 minutes later, and now the green color was getting a lot more obvious. All I did was just stir it around, and then I let it sit for something like another 30 minutes. By now, it looked like the red-orange color was pretty much all gone, and it was probably getting close to being done. However, I wanted to be really sure that there was no iron 3 left, so I let it sit overnight. This was what I had in the morning, and it wasn't exactly beautiful. There was still a lot of steel wool left, but there was also this whitish-green solid that had formed, which I think was just iron 2 chloride. I'm guessing there just wasn't enough water to dissolve it all, and it started precipitating out. This was of course quite easy to fix though, and I just added some more distilled water. I mixed it around as thoroughly as I could, and then like before, I just let it sit around for a bit. It eventually separated, and I saw that I had this really nice green solution, and now the next step was to get rid of all this extra junk. I did this by just passing it all through a regular coffee filter, and I drained it directly into the bottle that I was going to store it in. When everything had filtered through, I washed the beaker, the steel bowl in the filter, and the filter itself with a bunch of distilled water. When I was done doing that, I took away the funnel, and I topped everything off with more distilled water until I got to the level that I pre-marked on the bottle. This gave me a total volume of about 300 milliliters, and it let me calculate the relative concentration of this new iron 2 solution. For those that are interested, I've included all of the calculations that I did here, along with some extra details. But anyway, after this, I dropped in some iron nails. This iron 2 solution is easily oxidized back to iron 3 just by oxygen in the air. However, when these nails are added, it can reduce things back to being iron 2. At this point though, the iron 2 solution was ready, and I could now actually get things started. In my last video, I used my hot plate to stir things, but I found that it wasn't nearly fast or strong enough, especially to do it on larger scales. So I went and bought a nice overhead mixer from Amazon, which was basically just a high-tech milkshake maker. Also from eBay, I picked up a cheap Teflon-covered stir rod. Okay, so now equipment-wise I was all set up, but to actually make the magnetite, I just needed one other ingredient. This was concentrated ammonia solution, which is usually around 28%, and I picked up mine online. Now to get things started, I filled up this container with about 3 liters of distilled water, and I turned on some weak stirring. Then I added 60 ml of the iron 2 solution, followed by 75 ml of the iron 3, and I let it stir for another 10 minutes. During this time, I set up an addition funnel, and I filled it with about 100 grams of the concentrated ammonia. Also, you can see here that at this point, the RPM of the mixer was at 463. When the 10 minutes were up, I increased the stirring to about 1200, and I opened the addition funnel. Almost immediately, it formed a bunch of dark solid, but the mixer quickly scattered it, and it disappeared. As more was added though, it started sticking around, and the whole thing eventually turned brown. This was because when the basic ammonia was added, the pH slowly increased. When it got to above around 4, it started reacting with the iron 3 ions to make brown and insoluble iron 3 hydroxide. As more ammonia was added, the iron 3 ions were all eventually converted, and the pH continued to increase. When it got to around 9, it started converting the iron 2 ions to iron 2 hydroxide, but these didn't exist for very long. Almost immediately after forming, they combined with the iron 3 hydroxide to make black magnetite. Now, if all I wanted to do was make some generic magnetite, I wouldn't have needed this whole setup. I could have just directly mixed my iron 2 and iron 3, and even without stirring, dumped in the ammonia. The reason that I did it this way though, was because I needed the magnetite to form as nanoparticles. This part of the process was surprisingly finicky though, and I found that even just small changes in things like stir speed, or how fast I added the base, could really affect the final result. In general, I wanted to stir it as fast as I possibly could, because as the stir rate increases, particle size tends to decrease. However, the faster I stirred it, the more air got mixed into the reaction, which caused more iron 2 to get oxidized to iron 3. This altered the ratio of iron 3 to iron 2, and if this wasn't accounted for, the quality of the magnetite would be affected. For magnetite, the perfect ratio between iron 3 and iron 2 is 2:1. What I did instead though was use a lot more iron 2, and I added it as a ratio of 1.7:1. This way, when it oxidized and became iron 3, it would then be able to just combine with some of the excess iron 2. This gave me a bit of a buffer zone, and it allowed the reaction to be a lot more tolerant to oxygen. However, when the reaction was done, I also didn't want excess iron 2 still floating around. The speed that I added the base at also affected particle size, but this too was dependent on the stir rate. A faster addition could lead to smaller particles. However, if the stirring weren't fast enough, it could cause larger ones to form instead. So basically, if I stirred it too quickly, I might get too much oxidation, but if I stirred it too slowly, the particle size might become too big. On top of this, there were other variables, like how much extra water I had to include in this reaction, and things like temperature, and I had to find a balance between all these factors. It's definitely still far from perfect, but what I found worked was to do it at room temperature, with about a 20 times dilution, a stir rate of about 1200 like I said before, and to add the base over the course of 20 minutes. Adding the base did cause the mixture to slowly thicken though, so over the course of this, I slowly increased the stirring to around 1500. So 20 minutes later, I was done adding all the ammonia, and then I let it stir for another 15 minutes. While I was waiting though, I prepared the solution that I would use to stabilize the nanoparticles. This was done using oleic acid, which I got from eBay, as well as some more of the concentrated ammonia solution. So into a beaker, I added about 15 grams of oleic acid, followed by 20 ml of water and 10 ml of the ammonia. Almost immediately, the ammonia reacted with the oleic acid to form a soap called ammonium oleate. I stirred this around until it became a nice and thick goo, and it was basically ready. When it had almost just been 15 minutes, I went back to the reaction and I filled the addition funnel with 15 grams more of the concentrated ammonia. All of this ammonia was quickly added within about a minute. And when it was done, I checked the pH and I saw that it was nice and basic, probably just below 10. I then took away the funnel and I dumped in all of the soap that I had just made. It has a tendency to get stuck inside the beaker though, so to get it all out, I had to wash it a couple times with distilled water. I then let it stir over the next 20 minutes or so, and during this time, I slowly increased the RPM up to about 1900. What was happening here was an interaction between the ammonium oleate soap molecules and the magnetite nanoparticles. The charged polar ends of the ammonium oleate were being attracted to the surface of the magnetite. This caused them to adsorb to the surface of them and to stick out their long hydrophobic tails. One of the biggest issues with magnetite nanoparticles is that they tend to want to aggregate together and to stop being nanoparticles. With the ammonium oleate on their surface though, and with all these tails sticking out, the particles are stabilized because they're physically being blocked from coming together. On the surface, I started seeing a lot of brown stuff, which can be a bit scary because it might indicate some unwanted oxidation. I think it was mostly just soapy foam though that was filled with extremely small particles of magnetite. I of course could be wrong about that and it could be because of oxidation, but I just don't think that's the case. I originally took away the funnel because as this whole thing mixed, it slowly puffed up with foam and I didn't want it getting in the way. But now that it was almost done and it seemed to be relatively stable, I brought it back. This time though, instead of filling it with concentrated ammonia, I did it with dilute muriatic acid. This was made by just mixing 1 volume of the concentrated acid with 2 volumes of distilled water. Then once it had been about 20 minutes, I started adding the acid. Right now, this mixture was still very basic, with a lot of excess ammonia, and this was what the acid attacked first. This produced a bunch of ammonium chloride, and the pH slowly decreased. When most of the ammonia was eventually consumed, it then started attacking unreacted ammonium oleate soap, as well as the ammonium oleate that was on the surface of the magnetite. In both of these cases, it converted it back to being oily oleic acid, which was completely insoluble in water. This caused the magnetite to slowly separate out, and the goal was to bring the pH down to a bit below neutral, so around 6 to 7. For the majority of this acid addition though, things were pretty uneventful, and it didn't look like much was happening. All I did was just check the pH every few minutes to keep track of its progress. I also occasionally refilled the funnel with more 10% acid because it needed more than I could initially fit in it. When it did get close to being done, a lot of the soap foam had disappeared and the coated magnetite particles started separating from the water. In all the procedures that I read online, none of them used acid and they instead just did it by heating. This is because around 85 or 90 C, ammonium oleate starts to break down back into ammonia and oleic acid. The high heat then drives all the ammonia out of the water, and when it's eventually all gone, the solution is around neutral. However, I tried this in my last video and with some other test runs, and I never really found that it worked. It also just pushes a lot of ammonia gas into the air, which can of course be a hazard. On top of this, heating large amounts of water like this can be a pain, and it can take a really long time. So using acid is not only easier, safer, and faster, but in my experience, it actually gave better results. This finding is partially backed up by a random paper that I found which compared temperature with the quality of the oleic acid coating. They found that it was directly related, where as you increase the temperature, the quality got worse and worse. When it did eventually get to around the neutral point, the colors suddenly changed. The foam all very quickly turned white, and a lot of magnetite started separating out. This wasn't immediately evident though, because it was still stirring pretty strongly, but when I turned it off, it all quickly sank to the bottom. At this point, all the magnetite was ready, and now I just had to separate it from all the water and clean it up a bit. To do this, it was actually quite easy, and all I needed was a magnet, distilled water, and some rubbing alcohol. The first step was to get rid of all that extra water, so into a beaker, I dumped off as much as I could. Then using a magnet, I pulled out most of the particles. There were some that were still floating around, but anything that didn't get almost immediately pulled out was only weakly magnetic, and I didn't want it anyway. This water was then dumped off with the help of the magnet, and I did the same thing again. On the third time though, I was actually able to include a lot of the magnetite that was sitting at the bottom. And because of this, the separation with the magnet was a lot more interesting. The goal now was to separate all the magnetite into roughly 3 equal portions. Ideally, I would have just done it as one large batch, but the strongest magnet that I had wasn't strong enough to hold this much magnetite. What I had in the beaker at this point was probably the max that this magnet could handle. So once it had separated, I took it away, drained off the water, and I got a new beaker. Into this one, I poured in what looked like the same amount, did the same thing with the magnet, and then got a third beaker. To this last one, I added the rest, and I also washed the container with a bit of water to make sure that it got out as much as possible. When I put the magnet to it, it separated out like before, but there was a lot more here than the other ones. So once I was done and I had them all lined up like this, I tried to even it out. Now, the next step was to wash the magnetite, but because the process is the same for all 3, I'm just going to show you what I did for one of them. In general though, the process was really simple. I basically just had to add distilled water and mix it around. After doing this for a bit, and when I felt like I had broken up all the solid pieces, I put a magnet under it and I counted to about 5 seconds. The highly magnetic particles separated out really quickly, but the weaker ones needed more time. So not only did this let me clean up the magnetite and wash away reaction side products, it also helped me weed out some of the crappier particles. This water wash was done a total of 3 times, and then I moved on to washing it with isopropanol. What I did here was pretty much exactly the same, except I found that with the first couple washings with the alcohol, it always takes a bit longer for the magnetite to separate. So for these, instead of waiting about 5 seconds before dumping it off, I waited about 15 or so. By the third one though, it was a lot quicker, and the alcohol was also pretty much completely colorless. All the washing steps were now done, but I had to somehow get it all out of the beaker and into this bowl. Doing this manually though, with a spoon or something, is a huge pain. I found that the easiest and also the cleanest way was just to add some more alcohol, mix it around, and dump it into the bowl. I then separated the alcohol with a magnet and dumped it all back into the beaker. After doing this a few times, pretty much all of the magnetite was eventually transferred. With the magnet still stuck to it, I put the bowl upside down to drain away some of the alcohol. I then did the exact same washing process on the other 2 batches, and I put them here when I was done. About 10 minutes later, it looked like most of the alcohol had drained out of them, but there still was a decent amount in there. It was really important to get them completely dry though, and to do this, I used a vacuum chamber. This was the chamber that I used, and I got it from Amazon for around $100. The pump that I used was also from Amazon, and I got it a while ago when I was working on my transparent wood project. Along with this, it was also important to get some calcium chloride drying agent, and I picked some up from Home Depot. So now to the chamber, the first thing to do was to dump in a decent amount of the calcium chloride. And then on top of this, I made a small platform using styrofoam and a piece of cardboard. I put in all the bowls with the magnetite, and I also mixed them around a bit. Then I closed the chamber and I turned on the pump, but I didn't let it go to a full vacuum because sometimes this can cause things to splatter. I instead went to a certain point and then left the valve only slightly open so that the pressure would slowly decrease. By the time that it got to a full vacuum, it looked like it was behaving itself, so I fully opened the valve. After pumping on it like this for about 5 minutes, it looked like most of the alcohol was gone, and I closed the valve again. A few hours later, I repressurized the chamber, opened it up, and mixed things around. This wasn't really necessary to do, but I did find that it does help speed things up a bit. After doing that though, I put the lid back on, pulled another vacuum, and I left it overnight. Any alcohol or water that still remained just slowly evaporated, and it was continually picked up by the calcium chloride at the bottom. By the next morning it was ready, so I opened it up and I pulled everything out. At this point, it was a really dry powder, and I scraped off as much as I could from each bowl and combined it all into one. I also weighed it and found that it was a total of about 26 grams. When I first started making ferrofluids, I assumed that the magnetite at this point was going to be really oily and gross. However, it wasn't like that at all, and it was just a regular dry powder. The larger pieces looked really solid, but they were actually really easy to just break apart with my fingers and crumble them into a dust. One thing to be careful with though was that these were nanoparticles, so it was important not to breathe any of it in. But anyway, I had now successfully made the ferro part of the ferrofluid, and the next step was to add the liquid. When it comes to ferrofluids, there are oil-based ones and water-based ones, and it all depends what was used to cover the magnetite particles. And in my case, like we saw, I covered it in oily and non-polar oleic acid, so it would of course have to be an oil-based ferrofluid. For these types, the most popular solvent that people use is kerosene because it's cheap and easy to get, and it also doesn't evaporate as quickly as some of the other solvents. To make things easier, I split the batch roughly in half because I found that mixing large amounts can be a bit of a pain. For this half, I first weighed it, and it came out to be about 12 grams. I found that a good amount of kerosene to add is 85% of this mass, so I added 10.2 grams. The moment it was added, it all started dissolving, and the liquid quickly turned black. To be fully technical here though, the magnetite isn't truly dissolving, and it's just going into suspension. This is because the nanoparticles aren't soluble in the solvent, but they're small enough that they can still easily get dispersed. The oleic acid coating then helps with this by preventing the particles from coming too close together and by also allowing them to interact with the nonpolar solvent. The result of this is a stable suspension known as a colloid, where it's almost like the magnetite is being dissolved. Even after mixing it for a few minutes though, there was still quite a bit left. Sometimes it didn't really even look like much was happening, but it's just genuinely a really slow process. To speed it up, I could have just added more kerosene, but my goal here was to get it as concentrated as possible. When it eventually looked like it was pretty much all gone, I went and got one of my magnets. I found that when there was just a bit of solid left, it could really help, but also, it was just a decent test to see if the fluid was even working. When I brought it close, all the liquid pulled towards it, and it formed some nice spikes, which I was happy to see. Now in terms of mixing things, the magnet helps because it pulls all the solid stuff to one spot. It also holds it there pretty tightly, and it makes it a lot easier to squish it and to crush it on the side of the bowl. I just did the same thing for another 5 or 10 minutes, moving this glass rod back and forth, and eventually, it all pretty much disappeared. I was doing all this mixing over a board like this, so once it was done, I was able to test it by just putting a magnet underneath. When I did this, I was really happy with the results, because under the magnetic field, it didn't look like it was getting any more viscous or anything. In my opinion, this was one of the most important things to see, because it's what separates a proper ferrofluid from a lot of those DIY methods that are floating around online. What those make, especially the ones that just mix printer toner with an oil, are much closer to something called a magnetorheological fluid, or just an MR fluid for short. In an MR fluid, the particles are much larger, and because of that, they aren't able to stay suspended. So when they're exposed to a magnetic field, they start separating out from the solvent, and they increase the viscosity. Depending on the particle size and how well they're coated, this can sometimes cause things to partially, or even completely solidify. This all isn't to say, though, that MR fluids are a complete waste of time, or that they're useless, because they are interesting in their own way. While I was working on this project, I actually made them a few times by accident, but I thought that they were still pretty cool. For example, this one was a liquid, but when a magnet was brought close to it, it got a lot thicker. When the magnet was taken away, though, it almost instantly went back to being a liquid. I think this happened because some of them were small enough to stay suspended, but other ones were getting pulled out by the magnet. So what I had here was not fully an MR fluid, and it was kind of a mix with a ferrofluid. In other cases, though, when the run was a complete failure, I ended up with particles that were all way too big. So pretty much all of them were pulled out by the magnet, and the solidifying effect was much stronger. And because of all the solid content, it was still able to form spikes, but they were a lot sharper. But anyway, getting back to the ferrofluid, I find that it's a lot more fun when it's more spread out, so I poured it all into a larger dish. In my opinion, it was definitely a lot more fun like this, and I think the visuals were a lot nicer as well. The spikes kind of look like they're solid, but what's cool is that they're still completely liquid. They aren't able to hold up much of anything, so when I touched it with my glass rod, they just moved out of the way. What I thought was interesting, though, was that there was a bunch of liquid below the spikes, and this was able to hold up the rod. The magnetized fluid there was just really strongly attracted to itself, and it was surprising how strongly it repelled the rod. The fluid is only able to spike when the magnetic field passing through it is close to being vertical. So this was what happened when I put the magnet on the side, and most of the field was traveling parallel to it. It was only able to form spikes on the ends, and the middle was just a smooth blob. When I rotated the magnet, though, it gave this cool effect. What I had here was still only half the batch, so I went ahead and mixed the other part with kerosene, and I poured it all in. All of the fluid seemed to overload the magnet, though, so I decided to try it with a much larger one that I just got that morning. It seemed to be able to handle this much fluid a lot better, and the spikes were also bigger. At this point, I was pretty much done playing around with it, but I just wanted to show one last thing. I mentioned before that it didn't get more viscous under a magnetic field, but in general, it just wasn't very viscous at all. It was pretty much the same as just regular kerosene, despite being about half magnetite. From all the runs that I've done, I've noticed that the viscosity is actually something really important to look at, and every time that it's been thicker, it's been a really bad sign. Sometimes it initially works and it kind of looks like a ferrofluid, but then over the course of a day, it usually either separates or solidifies. Most of the time, those batches just end up being garbage, but sometimes they do end up being MR fluids, which, like I said, can be interesting in their own way. To measure the yield, I transferred it all to a grad cylinder, and it came out to be just above 30 mils. There was a small loss from all the stuff that stayed stuck to the dish, but in general, this was pretty much what I usually got. Now that we've seen what my fluid did, I just wanted to quickly compare it to the commercial stuff. So this here was just some of the commercial fluid that I bought, and this was what I made. The spikes in mine are significantly bigger, and in my opinion, they're also more impressive. The size of the spikes depends mostly on the concentration of the magnetite in the fluid, and I think that mine just had a lot more in it. In every run that I do, I try to saturate the kerosene, but because this process is still a bit finicky, I haven't gotten consistent results. This run just happened to be the best one that I filmed, but I did have some that I didn't record that were much higher quality. For example, in this unfilmed one, the spikes that I got were absolutely massive. Before making it, I honestly didn't even know that it was possible for ferrofluid to spike that strongly. The process that I did was almost exactly the same though, and I'm really not sure what caused the difference. However, I am working hard on figuring it out because having a fluid like this every time would be amazing. Now going back to the nearly empty dish, I put a magnet under it again, and you can see all these little spikes forming. I think that doing this on a small amount of the fluid is a decent test to see how good it is. When the fluid is high quality, it's easily able to form small spikes, even when there's barely anything there. I like to think of the magnetite nanoparticles as little pixels, where their size will determine the smallest spike that can form, as well as their resolution. When the particles are bigger and non-uniform in size, the resolution is bad, and they form larger and uglier spikes. When they're very small and uniform though, they make these really nice and little sharp ones. Now, besides just spiking the fluid on a dish, there are some other cool things to do with it. The first thing is to add water to a vial, and then to drop in some of the fluid. Kerosene alone is much lighter than water, but with all the heavier magnetite in it, it sinks to the bottom. Also, with all the water around, the ferrofluid no longer sticks to the glass. With magnets, I can then move it around, and it makes this pretty cool little toy. Sealing the vial was also quite easy, and I just had to fill it to the max with water, and then put the cap on. Now I honestly have no idea why, but for some reason, this thing never stops being fun to play with. At this point, I've had this thing for at least a few weeks, and I still find myself playing with it all the time. As a side note, I tried doing this with a couple different commercial ferrofluids, and it never seemed to work. By just smell, I could tell that they were kerosene based, but I think they also included a bunch of additives, which messed it up. Also, as a second side note, with the ferrofluid from this video, I've decided to make 5 more of these little vials and to give them away to viewers. I'll send them anywhere in the world, totally free of charge, and I'll explain how this will all work at the end of the video. I thought it would be fun to scale it up, so I just did the same thing with a larger bottle. However, when I did this, it was obvious that my fluid wasn't as good as some of the other runs. While it did still work and look cool, the spiking wasn't very good, and I also noticed that there were a lot of bubbles stuck in it. This made it look a bit chunkier and not as smooth as it should have been. For comparison though, this was another bottle that I made using that other batch that spiked really well, and you can see how much cleaner it is. It's just way smoother without all those bubbles, and it also spikes a lot more strongly. I'm really not sure why this batch turned out to be a lot more bubbly, but it must have had something to do with the surfactant. The preparation for both of them though were exactly the same, so I'm not really sure why there would be such a difference. Now changing gears a bit, another interesting thing with ferrofluid is that it's commonly used as a lubricant because it's able to stick to things like magnets and create a liquid cushion. With this, the magnet is able to stay completely separated from the surface and to slide around really easily. And while I definitely do think this is cool, what I found was more fun was to use it to make art. The cushion of ferrofluid also allowed the magnet to glide effortlessly over paper, and as it moved, it left behind a really small amount. The result of this were some shockingly smooth lines with extremely sharp and precise edges. Then, over the next 30 minutes, most of the kerosene evaporated and it became even glossier. I've never been very good at drawing, and what I did here was pretty much just at random, but for some reason, I thought that these simple designs were oddly interesting. I also tried a few times to do this with commercial ferrofluid, but it never seemed to work very well. There are some other oily additives in it which make it take way longer to dry, and it also tends to bleed into the paper. This makes it so that the edges aren't nearly as sharp, and also, the commercial fluid is more dilute, so it doesn't look as black. To be fair, this was just one commercial fluid that I tried this with, and there might be another one that works. I honestly really doubt that though, because pretty much all of the commercial stuff contains other oils and additives, but I mean, it could be possible. But anyway, I think that's about it for this project. I'm really happy that I was actually able to finally make ferrofluid, and that in some ways it was even better than the commercial stuff, but there's still a lot of work to do. My next major goal is to try and make the process a lot more reproducible, and to also scale it up. I'm not sure when that would be posted though, because for the time being, I'm kind of done with ferrofluids. They're insanely messy, and pretty much everything ended up getting covered with oily iron. Also, I've been thinking about ferrofluids way too often lately, to the point where I've been literally seeing them when I close my eyes. It'll probably be in something like several months, when I've forgotten how bad it is to work with, and I somehow convince myself that it's an awesome idea to revisit. But anyway, with all that being said, it's now time for the giveaway. Like I said before, I've made 5 of these files, and I'm gonna give them all away for free. I'll also ship them anywhere in the world, totally free of charge. To get a chance to win, all you need to do is use the link in the description, and then from there, you can get an entry by doing a few different things. This, for example, can just be as simple as visiting my YouTube pages, or by checking out my Instagram. And while you're there, you can feel free to subscribe or to follow, but it's not necessary for the giveaway. I'll do a drawing for the winners in about a week, and I'll post the results here on YouTube and on Twitter, and I'll personally email everyone that wins. With that being said though, I think that's finally it for the video. I hope you guys enjoyed it, and that the length of it didn't kill you, and I'll see you on the next one.